In this video, we are going to learn how to take the derivative of a natural logarithmic function. So the basic definition of the derivative of a natural logarithmic function says that if you're taking the log of some, we'll just call it function of x, then you're going to take 1 and you're going to divide it by whatever that function of x is, and then you're going to multiply it by the derivative of that particular function. So when we look at this first question that is asking us to find a second derivative, we will start with a first derivative. And so applying basic power rules here in the beginning, I get a 24x plus just a plain 2 plus a 0, which I don't have to show. And then when I take the derivative of the natural log of x, I'm going to say it's 1 over x times the derivative of x, which is just a 1. So that would finally be, that would become just 1 over x. So now when I go to take a second derivative, I'm going to think of, so let me rewrite my first derivative real quick. So we've got a 24x plus a 2. And instead of leaving that as 1 over x, I'm going to write it as x to the negative first power. It just makes it easier to do a power rule on that than to have to do a quotient rule. So now, as I'm ready to take my second derivative, the derivative of 24x is just 24. The derivative of the positive 2 is 0. And then when I go to take the derivative of x to the negative first, I get negative 1 times x to the negative second. And so notice they go back and they just rewrite it as a 24 minus a 1 over x squared. So they go back, and because of that negative power, they end up putting the x back in the bottom. So that is step 1. Step 2 wants us to set that derivative equal to 0 so that we can solve the equation for x. So if we take 24 minus our 1 over x squared, and we set it equal to 0, I would add the 1 over x squared to both sides to cancel it there. And so at this point, I would have my 24 is equal to 1 over x squared. And to get that x squared off the bottom, multiply both sides by x squared, so that we have a 24x squared that's equal to just 1. And then, if I go ahead and divide both sides by 24, then I'm going to be left with x squared equals 1 divided by 24. And the way that we go from having x squared to just x is we take the square root of both sides. We always consider both positive and negative. So I'm going to have x equals plus or minus. The square root of 1 on top is just 1. On the bottom, I have the square root of 24. But I'm going to think of the square root of 24 as the square root of a 4 times a 6, so that I can actually simplify that as 1 over, and then the square root of 4 would give me a 2, and then I would have the square root of 6 still on bottom. Now, they are going to expect me to rationalize this particular answer, and what that means is you cannot leave a square root in the bottom. So whatever square root we have on bottom, we're going to multiply by that square root on top and bottom. So square root of 6 on bottom, square root of 6 on top. And so once I do that and I simplify, I still have my plus or minus. Square root of 6 times 1 is square root of 6. On bottom I have a 2. And then when I take a square root of 6 times a square root of 6, I get the square root of 36. But I know the square root of 36 is just plain 6. So I end up with the square root of 6 over 2 times 6 would give me a 12. So my answer in simplest form, I'm going to have actually two answers, positive and negative, square root of 6 over 12 would be my x's. And now when I actually consider the original equation, if I go back and look right here, if I were to try to plug it in there, notice you're taking a logarithm of x. If you try to take the logarithm of a negative number, it does not exist. And so even though my correct solutions for x are plus or minus square root of 6 over 12, because going back to the original equation would produce something that does not exist, we actually throw out the negative answer. So my final value for x is just the positive square root of 6 over 12. All right, so the third part wanted me to find the possible inflection points. So if I take my positive square root of 6 over 12 and I put it on the number line so that I can test some points, I know that something such as, say, x equal 2 would be bigger, and then something like, we'll just say x equal, we can't take a negative, so I kind of need, let me get a decimal for square root of 6. Okay, so square root of 6 over 12 is approximately 0.2 as a decimal, so that means as a test point over here, then I will use something such as 0.1 as my test point. Okay, so as I go back to pick up my second derivative, my second derivative was equal to 24 minus 1 over x squared. So 24 minus 1 over x squared. Okay, so when I plug in 2, I get a 24 minus 1/4, so that is a positive value. So that definitely tells me that my particular graph is going to be concave up on this particular interval. And then when I plug in my 0.1, which you can think of as the fraction 1/10, you're going to get a 24 minus 1 over 1/10 squared, which you can do on your calculator. So 1/10 squared would be 1 over 100, and when you have 1 divided by 1 over 100, that just becomes 100 over 1. So the key is it's a negative number. So that tells me I'd be concave down. So definitely this is a point of inflection. That would be your x-coordinate, square root of 6 over 12. And then to get the y-coordinate, we of course have to come back to the original function to plug in our x. So let's see if I have room here. So if I take 12 times my square root of x over 12 and I square it, and then I have plus a 2 times my square root of 6 over 12, and then I have plus a 3, and then plus a natural log of my square root of 6 over 12. When I go to simplify that, on this first term, I'm going to have a 12 times square root of 6 squared would give me square root of 36, which is just plain 6. And then on the bottom, 12 squared would give me a 144. So we have a 6 over 144. And then on this second term, I would have a 2 times the square root of 6 over 12, which that's going to reduce in just a minute. And then, of course, I have my plus 3, and I have my plus my natural log of square root of 6 over 12. Okay. So now as I come back to simplify that anymore, 12 times 6 would give me a 72. Let me come down here, over 144. And I'm going to be adding the 3 to that. And so I'm going to have to get a common denominator there. I'm going to go ahead and reduce my 2 over 12. So that would leave me with square root of 6 over 6. And then I have plus my natural log of my square root of 6 over 12. And so here, I'd probably reduce first. 72 over 144 would give me a half. So if you're adding a half plus 3, that's going to be like saying 1/2 plus 6 over 2, so you end up with 7 over 2. So we have 7 over 2, plus we have a square root of 6 over 6, plus we have a natural log of square root of 6 over 12. And since they didn't ask for the decimal, this is all your y value all together. If they wanted a decimal, then you could actually punch it in.